I'm happy to announce the demo section now to the previous talk, because we didn't set it up like that, but I will show a few things that were contained in the previous talk, which is, I think, a nice fit. A few words about me. I'm Daniel Kahn. I'm from Austria. We were known for Mozart, maybe, Red Bull, and Californian governors as well. This is how we dress up on a regular Sunday, so that's... When I started in the industry, websites looked like that. Cats already dominated the internet, as we see here. JavaScript was wildly hated, actually, so I wouldn't have believed that I will kind of have a professional focus in JavaScript one day. Now I'm working for Dynatrace. We do performance monitoring. I will show a little bit later. And I'm doing the technology strategy for Node.js. This means, how could we monitor Node.js, talking with customers, also going to meetups and conferences and just finding out where the community is at when it comes to monitoring Node.js. This is how one of the products looks familiar. So data, metrics, telemetry about your processes. Last week I've been at Node Interactive in Austin. And this is the diagnostics working group here meeting up. That was a very productive meeting, and I'm happy that I can maybe tell a little bit about the outcomes here as well. And here we have Ali Sheikh sitting and Matt Loring of Google. Because every time we are talking about diagnostics and performance and debugging in Node.js, we always kind of rely a little bit on the V8 engine, right? Because that is where JavaScript runs at. So much of that, what I will talk about, is kind of using APIs that the V8 engine actually provides to us. During development, we actually usually ask ourselves some questions. So, does the program execution enter path X? That's a typical question. Do I ever end up there? Which values do my variables have at a given point in time? And why doesn't it work at all currently? So, that is where we enter actually debugging. As already discussed, so there are ways to quite easily debug Node.js. So that is with the dash will background the whole debugging system, and that will attach to this debugger. And I actually want to show you that, because that's way more exciting then. I'm using Visual Studio Code here because it's actually currently a really, really awesome Node debugging environment. So, may the demo gods be with me. I have to zoom it in a little bit. Zoom in. Okay, let's try that. Node. So that was now backgrounded. If I start it like that, actually the debugger comes up. So we see it here, and it stops at the first expression we have here. And now, if we are like the console people, we can run quite a lot of commands here. For instance, we can run it, we can continue it, we can create backtraces, whatever, create breakpoints, etc., which is already quite fine, but maybe not so convenient, right? So regular IDEs today provide us with quite some tools to make this better. And here in Visual Studio Code, you just have to click here. And then, if you do it for the first time, you click here to create a launch file for that. And so we are done. And then we can easily launch this program in debug mode, hopefully. And I can go into the routes here and maybe create a breakpoint, and hopefully, if I pull up Chrome and call localhost 3000, here we are. there we have this breakpoint, and the nice thing about this, so this is really a quite neat and full-blown debugger we have here. So when we hover over different variables we have here, we really get the current state of these variables, which is quite cool, I would say. And then you can do what you can do with every debugger, so you can kind of step through it, for instance, step into, step over, step out. So, and that is what kind of comes with Node.js quite out of the box. So this was debugging. So using Node debug, but there are various other ways as well. So I will show you that as well. That was yeah. In IntelliJ tools, you get this debug configuration as well. So you have this little debug icon next to your run configuration, and you can always run IntelliJ also in this mode, and it will give you more or less the same functionality. And then there is Node inspect, which is even nicer. For that, I again have to switch over here. Let's quit this here. Dash inspect in this case. Here we go. And here we get this URI, this Chrome URI. And that's quite magic, actually. So I copy this out here. And throw it into my Chrome browser, and it stops with a exception. Let's try it again. I had this when I was trying it as well. It worked the second time, so let's hope it's the case this time. So here we go. Debugger attached, looks good. Then I can look here into sources, and I think that's quite actually neat. So when I look here, here I have all those core stuff that is loaded already, and here I have all those. Can you read it even, or should I make it a little bit larger? Let's do it like that. Let's go here into routes, index.js, and here I can again, for instance, create a breakpoint, and it will work again like that. Or I can even make something like return .json hello world, and hopefully when I did it make a mistake? No. Ah, yeah, thank you. So now let's run this again. 3000, and here we go. Yeah, hello world. So we have really a live editing, debugging possibility directly built into Node. Most probably you don't want to use this in production, but not only overhead, also because of security. But I was actually, I don't know how you feel, but I was actually impressed when I tried this out that this works so flawlessly, actually. So that's another way to debug Node.js. Let's go. Here we go. And then there is, and that's a little bit funny, then there is Node-inspect, and that may be a little bit confusing. The background, so this is a module actually, and currently there is a discussion if it should land or be in any way part of Node core or not, because currently this Node-debug that is currently used is this protocol behind that is actually deprecated by Google. This means with upcoming versions this won't work anymore. And now Jan Krems created a Node inspect module that kind of uses the new protocol, gives you the debug functionality, but also the inspect functionality. So when you use now Node Inspect or debug, for instance, with Node Inspect, you get also the Chrome URI directly in your console and can use it like that. And that may be a little bit, that's why a cat picture comes into play, just to show how confusing this is actually. So this is something that may change in the future or may be part of Node.js and then transparent as well again. You see it here. So when you debug with Node Inspect, you get this Chrome URI directly here, and then the debugger attaches. So you can kind of, this brings together this inspect world and this debug world more or less. Other questions you have during, now not development, during production maybe. Where does my program spend its time, for instance? Or why is my CPU on 100%? And we heard before which reasons there are that such CPU problems can occur. And there is this very nice node-prof. And there is actually a post on the Node.js website that really describes that very well. I decided to use a little bit another approach and still use inspect, because if you use inspect in this case, and we have it still running hopefully, you have this profile tab here. And what you can do is you can start to record a CPU profile right here. And so I go to start, then I call my local host a few times. There is not much going on now, but most probably I get at least a little bit of data out of it. Then I stop here. And I have this chart. This is really boring now, but I can zoom in a little bit. Where are we at? Here we go. Here is our node process somewhere hidden. It's not so easy to do with the fingers.
Just use nsolid.
Yeah, definitely use nsolid. You see that is kind of, and nsolid is also something you want to use in production or in production scenarios, but here in development. So, but here you see a flame graph of the current CPU usage that you can use, which is during development can really help you big time. But I'll show you another way to do it in a second. All this. I just have to switch context again, because I personally prefer to do it using the V8 profiler. V8 profiler is nothing more than node module that exports functionality you have in V8 out to the JavaScript userland, and you can use it from there. And there you have this start profiling. You start it with some ID, and then you fetch the profile by stop profiling with the same ID, so you can start CPU profiles. What you want to do obviously is you want to have some time going by between the start profiling and stop profiling, and then you see everything that was going on in this time slice. And when I was trying out to how I can maybe find a way to utilize that or find out if this even works, I used this and I fed it to D3, this JavaScript charting library, and created sunburst charts from that. And my approach was trying to run Express, a simple Express app with Node environment in development or in production. And as we see, and I think that's very easy to grasp here, that on the left side there's much more going on, right? So it's very visual when you use sunburst charts, what's really going on. And you can even take it further, because I can hopefully click on it. And somewhere, hopefully a browser opens. Here we are. Maybe we have network problems here. Let's see if it works. Also, the server was relocated recently. Oh, here it is. So this is the sunburst of running an Express application in development. And when we want to know what's really going on, so here is the stack, what's on the CPU at this given time, and you see that there is much going on. And actually this is all Jade compiling in this case, because I was using the Jade templating system, and it makes totally sense for Jade in development mode to recompile all HTML files or all Jade files with every request, because you just want to know what you just changed. And that is why you see that there is a lot of string processing here going on. And this is causing actually the whole performance hit when you run Node in development mode. What you can also do, if you like it, can even drill into that and then look closer into what's really going on. And this is all done with CPU profiling data fetched via CPU V8 profiler and getting the profiles and loading that to D3. It's a JSON file, so it's quite easy to do. Maybe one a little bit neat thing about this is that Express, when you don't explicitly set the node environment here, will always default to development. And then Jade, consequently, will also default to development, and then this recompilation will take place. This means when you, just for testing locally, run your node process without any parameters, you will most probably run in development mode. And this means if you do performance checks locally, you won't get the real data out of it. It's actually around 70% slower to run in development mode. So that's quite a lot. I did another try. We had this Node.js in Flames problem. I don't know, does anyone know about this problem? Who else? So then I can tell the story real quick. So Netflix was blaming Express because they said, yeah, we have a problem. Every few hours, the latency of our node processes goes up. And we have to restart everything again and again. And they looked a very long time to find out what's the cause for the problem. And they found out that they thought that the routes in Express are actually a map as data structure. This means on the left side you have the route, and on the right side you have the function to be called when the route is called, like index or whatever. Actually, and it makes totally sense, the routes in Express are arrays, so there can be duplicates. They had a script that created those routes automatically, and now they were blowing up the routing table all the time. And because they were thinking duplicates are no problem. And they ran into a classical O of n problem. So because at some point really Express had to run through all, or Node had to run through all those routes to find the matching one, and that was really a problem. The reason why Express uses array and no map is there can also be regular expressions, as you see here down here, regular expressions as route, and so there is no way to create something like a map that kind of allows that there is no duplicate. And again, I tried this, so I created a little script that created routes wildly and ran some requests against it. And then I took the CPU profile, and again, this finding the route, this, as you see here, this is some regular expression against the route here, and this is all the route finding you see here. So that was for me a viable showcase that using these CPU profiles you can really solve real-world problems. Next questions we have. What is in the memory and where is the leak? In the previous talk we heard already that there are ways to confuse the V8 engine, the garbage collector, so far that it cannot really deconstruct all those references. You can actually do, 1 second, just have to switch those timings off. So, and this is an example from the Meteor project. that really builds a lovely memory leak that isn't really, you won't know it if you look at it, because it's not wrong, it's not faulty code, everything is fine here. The problem is simply that there are references and closures created that the V8 engine cannot deconstruct anymore. I will post the slides later for everyone that wants to go through all of that. I've created a little bit of a drawing here. So we have this root namespace, and we have an object that is called the thing, and it contains a long string. And in there is some method that it's actually never called. The thing is hooked to the root namespace. Then we have an unused function within this route that has a reference called original thing, which again points to the thing. And then some method inside the thing it's complicated, but this drawing is nice. The thing, and I did it so often already, and I still have kind of a hard time to explain, but still. So some method has the closure context to unused. This means every closure you have in JavaScript has to know its surrounding context, because you can use the variables in there. So it has to hold a reference. And this is, if you know how a heap works, a heap is kind of a graph. And an object can be disposed if no incoming paths are anymore here to this object. Then it's not used anymore, and then it can be disposed. Using this, you can confuse the V8 engine so far that it will actually not garbage collect, and it will blow up in a memory leak. And this looks, when you run a graph through it, it will look like that in this case. And again, you can use those dev tools I've shown you before to create such heap snapshots at any given time. And you can even create a heap snapshots over time and run requests against this process and see what's going on. Because when you're dealing with heap problems, you always want to know the delta, because you want to know a progression. It does not help you when you know at this point in time the heap has this state. You want to know how did it develop over the last 30 minutes, for instance. And this is how you can do it. And here we see this is the long string. I just had asterisks in there. And here you see this context. And so this chained context that really, a closure context that really causes this problem here. So that's how you can find memory problems. And as already said, it's hard. Still, because it's not even always so easy that you have a string of asterisks that is easy to spot, but it's how you do it actually. So you can do it also using V8 Profiler again. V8 Profiler can always help you if you want to do this programmatically. If you want, for instance, build something into your code to switch on CPU profiling if some memory threshold, for instance, is exceeded. So you can see, okay, in the last 30 minutes, the memory kind of was growing constantly. Let's take a CPU snapshot, and you can do this with V8 Profiler. So you can kind of add traps to your code that will help you find heap problems, or you use nSolid. There is another problem you may want to try to tackle, because it's not always just your node process, right? So you want to know, how do all my services communicate with each other? Is maybe the backend slow, and that is the reason why the website is slow, that is rendered by Node.js? Or where is the cause of this current degradation we are facing? That's now transactional tracing, because usually, and that is how we see Node most of the time, Node is used like that. So you have some Node process that proxies and really fetches data from various data sources. It's not, Node is so strong because it can asynchronously fetch data from different sources, transform it, and provide it to different, in different formats. For instance, for HTML5 website with WebSockets, for instance. What Tomcat, GSP, whatever thing could not provide to you. You can do this through Node. And there is where the trouble starts, because you actually cannot really know when there is something going on and something going slow in Node. You cannot really know if not something down the stack is really the root cause here. And this is where transactional tracing comes into play. So this means you want to have agents deployed to every tier of your whole application stack, including Node.js, so that you really can collect data through the whole process. And we have to do it by really starting in the browser, creating some ID, passing this through all tiers, no matter if you're using queues or regular REST, whatever. We really pass through this ID through all processes. And for every technology, there is an agent sitting that gets the ID, reports it to our server, and says, OK, there is a new request coming in with these parameters, etc. With Node, this is not totally easy to do, because for every other technology, or most technologies, it's like that. If a request comes in, a new thread is spawned, and you know this one thread now handles this request. So you can create an ID that runs on this thread local. For Node, it's like that. You have this single thread model, and all requests are handled by this one thread, so you cannot rely on that. So what we face and are facing all the time is something we call context loss. This means we have maybe some find one method of some exotic database, and there is this callback, and we don't instrument this callback, so we don't pass in our ID, our context, into these callbacks, and this now runs through the event loop, comes back, and then we lose the context. And when then there is an outgoing HTTP request again, we cannot pass our context beacon to it, and then we kind of are screwed more or less and cannot proceed creating our pure paths here. And this is quite a problem in Node.js, actually, and quite unique to Node.js. And I can only recommend you to watch the talk of Thomas Watson of Upbeat, because he really spent a whole talk about explaining why it is so hard to do transactional tracing in Node.js. The goal, in the end, is getting something like that for every given technology. This means you really have your whole uber complicated stack, and you can really trace from the user down to the database. And when there is something slower going on, you will see it instantly, because here it is. You have measurements for every transaction running through your application. And even more, and I think that's also an important thing, especially for microservice architectures, is to see how are my services and my APIs even communicating with each other, right? Because maybe you have a constraint set that you want a microservice only talks through an API with the database. But now you see that team XYZ started to talk directly to the database, or there is a new API, no one knows where it's coming from, because we are microservices, every team can choose how they do it and which technology, etc. So there can be many problems coming up because architectural constraints are not met. And this is what you can track with transactional tracing. Because it can also look like that. That is microservice architecture we call Destar. And it's real, so that's how it looks like, and that's quite hard to process, actually. And then there are other questions, like what happened yesterday at 6 p.m. when our conversions dropped, or how is the performance in China? So here we are at monitoring. This is when we add the time component to this whole tracing, debugging, whatever. You want to know what is the progression of our problems and how are our services doing. And that is what actually our products do. And I just provide you a little bit of a demo without doing shameless self-promotion here. If it's still here, 1 second. If the network gods don't fail me. Otherwise I have screenshots, so So here we have something we call Smartscape. So this really shows you every process or every service of your whole infrastructure. And what you actually most probably want, and that is where this monitoring approach comes into play, is you want to have first an overview, and you may want to know how our users maybe in China doing real user monitoring, really adding geographical data to your monitoring to know are there some maybe CDN problems at some place in the world, or and that is I think the most important thing is as infrastructures and applications get more and more complex, you don't really want to deal with drilling into every problem and always be on the lookout if there is a problem. You actually just want to know when there is a problem, where it is coming from. You don't want all those details, and this is what this solution actually provides to you. I hope maybe I have a problem here that kind of relates to Node.js. I cannot guarantee it. Here we have user action duration degradation, for instance. And yeah, that's a nice one. So you have a problem. The system will do this transactional tracing, gather information from every given process you have, be it Node.js, .NET, or the database. Puts this together in one big data warehouse, constantly analyzes what's really going on, and will then, if there's a problem, most probably it is when users start to get affected, the website is starting to get slow. It will then really show you the root cause, which is in this case a network problem. And yeah, you would have to look for a long time to really find this out. So really talking with many people to find out where the root cause is. And if you really are curious about how this whole problem, so how the shit hits the fan, actually, you can really scroll through everything that's going on here. It's just the user all the time. It's a little bit boring. Yeah, here you see it, yeah. So you can swipe through this, step through this problem progression to really see, okay, how this problem happened. And everything you see down here is what you would usually, if you employ your own maybe monitoring, or every team kind of creates their own monitor solution. Everything you see here, this would be an alert you get on your phone. But are you really interested in all those alerts that are just consequences of a problem that is maybe just a network problem? So, and this is what you get using this transaction monitoring we do. Coming soon. There are a few totally exciting things coming up. There is excitement. Giphy, yeah. So there will be tracing controller in Node.js, and we discussed this last week again. So Matt Loring of Google created a tracing controller that uses the trace events of the V8 engine. This does not sound as exciting as it is, because it helps. So the future is that from JavaScript you can create trace events, write it to Node, you can categorize them, and it just in Node and V8 has a separate thread that handles really and takes care of all those trace events, and you can then query it from different sources. This is kind of your, I don't know if you know this debug module maybe for Node.js. So, but this is the deluxe version, because when you don't switch on anything here, or so you don't attach the tracer to it, and you don't subscribe, and now this happens to me as well. So I have to start anew a little bit. So from your user land, you can create trace events. They will be written to the tracing engine of V8, will create not really almost no overhead if you don't switch tracing on, but you can consume those tracing events and, for instance, look them up in Chrome Developer Tools again, which gives you a lot of debugging possibilities for your code. And what will and has to come as well, accompanying that, is that there will be tracing events directly in Node Core. This means Node Core will create those tracing events as well that you can subscribe to really see, I don't know, open handles, or how many open file descriptors were just opened, or how long does it take for this network request to come back. So this will be part of Node Core, and this will help you most probably to also trace down some event loop issues, etc. So it really depends then on Node Core, how many tracing events are created, and if module author use this as well. But if we get this really end-to-end, and if this is done like that, we get a real tracing bus in Node.js, and you can always connect to it and really have real-time telemetry of your process, which is a really great thing, because you can do a lot with it. And then there is this async hooks module, which will solve more or less, hopefully, this problem of asynchronous tracing in Node.js, because it allows you to carry over context through callbacks. And this will also help big time for everyone that does monitoring or anything like that in Node.js. And this is all coming up in the next few versions. I recommend, and you can use the link on the slides later then, to watch this video where this tracing controller is shown, because it's really great to also see Matt kind of describing what he did actually does and how it works. So look that up. Further information. Node.js is interesting because it has a very, very open process of communication. So everything that's going on within the Node project is basically built on working groups. And there is also a diagnostics working group. And you can all the time, on GitHub, you see what's going on, and you can always look up the meetings we had. There are even videos of it, so you can and always participate in the process of the diagnostics working group, as with every working group you have in Node, which I highly recommend, because there you get all this information. Much of what I told you in this talk you will find here as well, and also code for that and examples, etc. You can, if you want, also read what I write in our company blog, but because it's mostly about Node.js and it covers all those performance topics, of course you can try Dynatrace if you want to. And that's for me. Thank you.